Good morning and welcome to today's webinar entitled OSHA's Respiratory Protection Standard 29 CFR 1910-134. My name is Brian Brocker. I'm a safety and health consultant with the PA OSHA Consultation Program. The purpose of today's webinar is to provide an overview of the OSHA's 29 CFR 1910-134 Respiratory Protection Standard Regulation. If you have any questions, please submit them through the chat feature. Questions should be specific to the topic. For any other questions, contact our program via phone or email for additional assistance. The webinar recording and questions and answers will be posted on the IP OSHA consultation website within 1 week. The standard applies to general industry 1910, shipyards 1915, marine terminals 1917, longshoring 1918, and construction 1926. So it basically applies to all industries in those areas, and they all reference back to this standard 1910-134. Any revisions to specific standards that reference back to respiratory, if they have respirator-related provisions of the OSHA existing standards, were revised to conform to for each other and covered under 1910-134. All provisions addressing respiratory use, selection, and fit testing are deleted from the OSHA specific substance-specific standards and are covered in 134 as well. Organization of the standard. This is basically how the standard is set up. Section A is permissible practices. Section B is definitions. Section C, respiratory program. D, selection respirators. E, medical evaluation. F, fit testing. G, use of respirators. H, maintenance and care. I, breathing air quality and use. J, identification of filters, cartridges, and canisters. Then you have K, training and information. L, program evaluation. M, record keeping. N, dates. O, appendices. Mandatory includes the fit testing procedures. Section B1 is user seal checks. B2, cleaning procedures. C, medical questionnaire. And D, information for employees wearing respirators were not required under the standard. I'll go over the majority of these in a little more detail, obviously. Some will be in less detail. Permissible practices. The primary means to control occupational diseases caused by breathing contaminated air is through the use of feasible engineering controls, such as enclosures, confinement, cooperation, ventilation, or substitution of less toxic materials. When effective engineering controls are not feasible, or while they are being instituted, appropriate respirators shall be used pursuant to this standard. Employers shall provide respirators when necessary, when they're applicable and suitable for the purpose intended. The employer shall be responsible for establishment and maintenance of respiratory protection program, which includes the requirements of paragraph C of the respiratory protection program. Definitions. I'm not going to go through all of them in the standard, but I'm going to hit some of them. Employee exposure. Exposure to concentration of airborne contaminants that would occur if the employee were not using respiratory protection. Respiratory inlet covering. The portion of the respirator that forms the protective barrier between the user's respiratory tract, which is your nose and mouth, and air purifying device or breathing air source, or both. It may be a facepiece, helmet, hood, suit, or mouthpiece respirator with nose clamp, as we'll show in the next slides. There you see a quarter mask over the nose and underneath the lip. Half mask goes under the chin and over the nose. Full face covers the outside face from the forehead below the chin, and the mouthpiece just sits inside the mouth. Loose fitting respirators. You can see there's a blast hood, helmet, loose fitting face piece. You see a lot of these on powder purifying respirators, and then a full body suit in the bottom there. Oops. Filter or air purifying element. It's a component used in a respirator to remove solid or liquid aerosols from the inspired air, or the air intake or the respiration. This would be a filter or a cartridge. Canister or cartridge. A container with a filter, sorbent, or catalyst, or combination of these items, which removes specific contaminants from the air passed through the container. You can see different methods there. You have that's actually a 3M one, but you see other ones that are like this one over here, and that's for a canister there. Filtering face piece is a negative pressure particulate respirator. I'm sorry, filtering face piece next. Negative pressure respirator, a respirator which the air pressure inside the face piece is negative during inhalation with respect to the ambient air pressure outside of the respirator. Sorry, now we'll get to the filtering face piece. It's a negative pressure particulate respirator with a filter as an integral part of the face piece, or with an entire face piece composed of filtering medium. No elastomeric touching the face, or rubber touching the face on these. Air purifying respirator, or APR. It's a respirator with an air purifying filter, cartridge, or canister that removes specific air contaminants by passing ambient air through the air purifying element. This is the filter or cartridge. This here's a cartridge. This here's a filter. You suck air through that, and it filters out the contaminants. Positive pressure respirator. It's a respirator in which the pressure inside the respiratory inlet covering exceeds the ambient air pressure outside the respirator. So you can see it usually has either plant air, or you can have a compressor, runs through a hose, actually runs through filters, runs through a hose to the face piece, or in this case down here, looks like he might be doing some blasting. Maybe not, but he has an air hood on the respirator. Powered air purifying respirator, or PAPR, PAPR, an air purifying respirator that uses a blower to force the ambient air through the air purifying elements to the inlet covering. Basically, you have your battery pack sitting here or here, and it pulls air through, and the filter's right in there as well, through the air and into. This is a welding helmet, and this is a full face respirator. In this case, battery pack's here, and it powers the motor here with a filter there through the face. There's different configurations how these can be set up. Atmosphere supplying respirator is a respirator that supplies the user with breathing air from a source independent of the ambient atmosphere. It includes supplied air respirators, or SARS, and self-contained breathing apparatus, or we call scuba units. This one here is coming from a pump, as we showed in the other picture, pumps air through, and usually there's a vortex or something to control the airflow here, or sometimes temperatures, goes through the air. And then the SARS, or self-contained breathing apparatus, you have a tank, has independent air that blows through the regulator and into the face piece. Classes of atmosphere supplying respirators. You have continuous flow. That provides continuous flow of breathing air to the respiratory inlet covering. Demand, it admits breathing air to the face piece only when negative pressure is created inside the facepiece by inhalation. Pressure demand allows breathing air into the facepiece when the positive pressure inside the facepiece is reduced by inhalation. Supplied air respirator, or SAR, airline respirator, is an atmosphere supplying respirator for which the source of the breathing air is not designed to be carried by the user. Again, we talked about these already. You have the pump, or you have plant air. Breath through, then you have a longer hose, so you can walk around, but you don't have the heavy device to carry around with you. Self-contained breathing apparatus. That's atmosphere supplying respirator for which the breathing air source is designed to be carried by the user. In this picture here, kind of cut it off a little bit, but the tank's in the back and the hose goes through your regulator. Sometimes they're on your facepiece, sometimes they're down here and into the facepiece. Bear with me. Escape only respirator. It's respirator intended to be used only for emergency exit. There's not a whole lot of air in there. It's just enough to get you out. In this case, you could have a full face, whatever, but usually you have something like a bag or somewhat of a loose fitting device you stick over your face, and it's enough to get out in an emergency situation. It's not working. Next, you have the respirator program. You have the written program, worksite specific procedures when respirators are necessary or required by the employer. Must update the program as necessary to reflect changes in the workplace conditions that affect respirator use. Must designate a program administrator who's qualified by appropriate training or expertise to administer or oversee the program, conduct the required program evaluations. Must provide respirators, training, and medical evaluations, all at no cost to the employee. OSHA has prepared a small-end compliance guide that contains criteria for selection of a program administrator and sample programs that you can refer to. It's on the OSHA's website. More on respirator. This is where respirators are not required. If they're not required by regulation or by the employer, you can use them voluntarily. The employer may provide respirators at the employee's request or permit employees to use their own respirators if the employer determines that such use itself will not create a hazard to the employee. Voluntary use is permissible. The employer must provide users with information contained in Appendix D of the respirator standard. Must establish and implement those elements of a written respirator program necessary to ensure that the employer is medically able to use the respirator and that it is clean, stored, and maintained so it does not present a health hazard to the user. If the employers are not required, included in the respirator program, employees' only use of respirators involves voluntary use of filtering face pieces. There you only have to give them Appendix D. Elements of a respirator program: you have selection, medical evaluation, fit testing, use, maintenance and care, breathing air quality, training, and program evaluation, which I will go into those elements separately. First, you have selection respirators. Selection is the employer must select the respirator and provide an appropriate respirator based on the respiratory hazards to which the worker is exposed and workplace use factors that affect respirator performance and reliability. And there's more on types of respirators. We have a Facepiece respirators with a Facepiece. You have quarter mask and full and a half. You have positive and negative pressure. You have loose and tight fitting. You have air purifying, air supplied respirators. With the half mask, you have negative air purifying respirator. You have full face negative pressure air purifying respirator. You have power air purifying respirator, which is positive pressure. It's air purifying. You have supplied air respirators, which is positive. This includes your safe contained breathing apparatus, bottled air, compressor. More on selection. You want to select a NIOSH certified respirator that shall be used in compliance with the conditions of its certification. Identify and evaluate the respiratory hazard in the workplace, including reasonable estimate of employees' exposure, identification of contaminants, chemical state, and physical form. Where exposure cannot be identified or reasonably estimated, the atmosphere shall be considered immediately dangerous to life and health. You want to select respirators from a sufficient number and models and sizes so that the respirator is acceptable to and correctly fits the user. Some information, next several slides are on immediately dangerous life and health situations. Oops. Sorry. Immediate dangerous life and health situation, IDLH, is an atmosphere that poses an immediate threat to life and would cause irreversible adverse health effects or would impair the individual's ability to escape from the dangerous atmosphere. Oxygen deficient atmosphere is an atmosphere with an oxygen content below 19.5% by volume. All oxygen deficient atmospheres are considered immediately dangerous to life and health. Respirators are immediately dangerous. For respirators for all immediate IDLH atmospheres, you should have a full face pressure demand, self-contained breathing certified by NIOSH for a minimum service life of 30 minutes. Or a full face pressure demand supplied air respirator or auxiliary combination self-contained air supply. Respirators only for escape from IDLH atmospheres need a NIOSH certified for escape from the atmosphere which it will be used. It's an exception. Employers may use any atmosphere supplying respirator provided they can demonstrate under all foreseeable conditions that the oxygen levels in the work area maintain between 19.5% and lower value that corresponds with an altitude adjustment oxygen partial pressure equivalent of 16% oxygen at sea level. Assigned protection factor. This is actually definitions at APF. It's the workplace level respiratory protection that a respirator or class of respirators is expected to provide to employees when the employer implements a continuing effective respiratory protection program as specified in this section. You must use the APFs listed in Table 1, which is going to be our next slide, to select the respirator that meets or exceeds the required level of protection. When using combination respirator, for example, airline with an air purifying filter, you must ensure that the APF is appropriate to the mode of operation for which the respirator is being used. Here on this side, you can see different. This is Table 1 of the 1910-134. You have quarter mask, half, full, helmet or hood, or loose fitting across the top. You have air purifying, PAPRs, supplied air, and self-contained breathing apparatus one down the side. Quarter mask will provide you air purifying of 5, half mask 10. If it's a power air purifying, it'll give you 50. Again, if it's supplied air, you get 10 on demand. Continuous flow, you get, or pressure demand, you get 50. Self-contained breathing apparatus demand, you get 10. Full face, you get an APF of 50. The power air purifying full face, you get 1,000. Just the same as the supplied air continuous and pressure demand flows. For just a demand flow, you get 50. A helmet or hood, you don't have an air purifying one with that, but a power air purifying typically gives you 25. You'd have to show that it's 1,000. The manufacturer would have to demonstrate that it meets that criteria and document that for you, and you get the same out of supplied air respirator. Get into loose fitting powder air purifying, it's 25. Continuous flow, it's also 25. That's a good reference table for you when you're selecting your respirators. Maximum use concentrations, or MUC, another definition. The maximum atmospheric concentration of a hazardous substance from which an employee can be expected to be protected when wearing a respirator, and is determined by the assigned protection factor, the APF, of the respirator or class of respirators, and the exposure limit of the hazardous substance. Example on here, maximum usable concentration is the APF times the PEL, the exposure limit. When no OSHA exposure limit is available for a hazardous substance, the employer must determine the MUC on the basis of relevant available information by an informed professional judgment. Oops, sorry. Maximum use concentration must maintain a respirator that you must select a respirator that maintains exposure to the hazard substance when measured outside the respirator at or below the maximum usable concentration. The MUCs do not apply to IDLH atmospheres. When calculated, the MUC exceeds immediately dangerous to life and health atmosphere or performance limits of the cartridge or canister set maximum usable concentration at the lower limit. Select a respirator appropriate for the chemical state and physical form of the contaminant. Here's an example. What is the maximum usable concentration for an employee wearing a half-mask air purifying respirator with an APF of 10? An atmosphere of sulfur dioxide gas, PL 5 parts per million. Going through the formula of an APF of 10, OSHA exposure limit of 5, you can use that respirator up to 50 parts per million. And another note the calculator does not exceed the immediate dangerous to life and health, which is 100. So the maximum usable, this example is 50 parts per million. More selection. Respirators for atmospheres not IDLH gases and vapors, atmosphere supplying respirator or air purifying respirator. If you have an end of life service indicator, that is over here, you'll have a color change whenever the indicator shows, or in this one down here, it'll change colors indicating that its service life is exhausted. If you have no end of life service indicator, create a change schedule based on objective information or data, ensuring the cartridge is changed before the end of their service life. When described information and data relied upon and basis for the change schedule and reliance on that data. So you want to document how you made that determination. For particulate respirators that are not IDLH, the employer must provide an atmosphere supplying respirator or an air purifying respirator equipped with a HEPA filter certified by NOSH under 30 CFR Part 11, or with filter certified for particulates under 42 CFR Part 84, or an air purifying respirator equipped with any filter certified for particulates by NOSH for contaminants consisting primarily of particulates with a mass median aerodynamic diameter of at least 2 micrometers. Different classes of non-powered air purifying particulate filters. There's actually 9 classes if you look at them. 3 levels for filter efficiency or percentage, each with 3 categories of resistance. Resistance to filter efficiency, the degradation due to the presence of aerosols. And you have NPR, N is not resistance to oil, R is resistant to oil, and P is oil proof. So there's your three, and then you have 100%, 99%, and 55%. So 3 times 3 is 9 classes. Excuse me. Again, NPR 100 is 99% efficient, and 95, 99, 100 clearly marked, or definitely clearly marked in the box. If no oil particulates are present, use any series, NP or F. Yeah, NP or R. If oil particulates are present, use only R or P series. If oil particulates are present and the filter is to be used for more than one shift, use only the P series. Follow the respirator filter manufacturer's service time limit recommendations. High efficiency filters, they are 99, basically N100 filter is 99.97% efficient for removing monodispersed particles of 0.3 microns in diameter. HEPA filter per NIOSH 30 CFR 11. The other one is equivalent to NIOSH 42 CFR 84 particulate filters are N100, R100, or P100. Bear with me here, sorry. Now on to medical evaluation. The procedure must provide before fit testing and use to determine employees' ability to use a respirator. Must identify primary licensed healthcare physician to perform medical evaluations using, and that's PLHCP, to perform medical evaluations using medical questionnaire or initial medical determination that obtains the same information. Physician or other healthcare professional, PLHCP, is an individual who's legally permitted to scope practice, i.e. licensed, registered, or certified, allows him or her to independently provide or be delegated the responsibility to provide some or all the healthcare services required by paragraph E of the medical evaluation. Sorry about that. Medical evaluations must obtain the information requested by the questionnaire in section 1 and 2, part A, appendix C. Follow-up medical evaluation is required for employees who give positive responses to any question among questions 1 through 8 in section 2, part A, appendix C, or whose initial medical examination demonstrates the need for follow-up medical examination. Additional medical evaluations. An annual review of medical status is not required. At a minimum, employee must provide additional medical evaluations if employee reports medical signs or symptoms related to the ability to use a respirator. PLHCP, supervisor, or program administrator informs the employer that an employee needs to be re-evaluated. Information from the respirator program, including observations made during the fit testing and program evaluation, indicates a need. Change occurs in workplace conditions that may substantially increase physical burden on the employee. Before a negative or positive pressure fit test, pressure tight fitting facepiece, employee must first be fit tested. So before using the negative or positive pressure tight fitting facepiece, you want to use the same make, model, style, and size of respirator to be fit tested. The fit test must be administered using an OSHA accepted qualitative fit test, QLFT, or quantitative fit test, QNFT, protocol contained in Appendix A. A qualitative, or QLFT, is a pass-fail type of fit test. It's used to assess the adequacy of the respirator fit that relies on individual's response to test agent. You're going to basically, in this picture here, you have like a bag over your head with a window and a little hole, and they will insert either isoamyl acetate, saccharin, Bitrex, or irritant smoke. And the employee is going to do a series of tests. And if they can smell it, that means it's leaking. They can readjust it, or try, if that doesn't work, they can try a different size. The irritant smoke generally is little more obvious because it causes you to cough, and it's a response for the employee without somewhat involuntary. Let's find the mouse. A quantitative fit test is a little more detailed. The assessment of the adequacy of the respirator fit by numerically measuring the amount of leakage into the respirator. The quantitative protocols include, there's 6 types. You have a generated aerosol, colloidal salt, or DEHP. You have a condensed nuclei counter, CNC, or porta count. You have a modified condensed nuclei counter for full or half mask elastomeric respirators. It's CNC porta count, and uses different exercises. A modified condensed nuclei counter for full half elastomeric respirators, CNC porta count, also with different exercises. You have a controlled negative pressure, Dynatech Fit 3000, an example of that. You have a controlled negative pressure, CNP, or Redon. Fit testing continued. Employees using tight-fitting face respirator must pass a qualitative or quantitative fit test. Prior to the initial use, whenever a different respirator is used, and at least annually thereafter. An additional fit test must be conducted whenever an employee reports that there's an issue, or the employer or PLHCP makes visual observation of changes in employee's physical condition that could affect the respirator. Fit factor is a quantitative estimate of the fit of a particular respirator to a specific individual, and typically estimates the ratio. And that ratio is the concentration of substance in ambient air divided by the concentration inside the respirator when worn. The qualitative test may only be used if fit test, negative pressure, air purifying respirator must achieve a fit factor of less than 100. If the fit factor as determined through OSHA accepted quantitative protocol is equal to or greater than 100 for tight-fitting half mask face pieces, or equal to or greater than 500 for tight-fitting full face pieces, the quantitative has passed the respirator. Passed the respirator fit test, sorry. Use Facepiece seal tight-fitting respirators. No facial hair or any condition that interferes with the face-to-face seal or valve can be used. So any beards or anything like that, or other interferences cannot interfere with that seal. Corrective glasses or goggles or other PPE must be worn in a manner that does not interfere with that seal. Employees wearing tight-fitting respirators must perform a user seal check each time they put on the respirator, using procedures in Appendix B1 or equally equivalent manufacturer's procedure. Basically, with the user seal check is an action by the respirator user to determine if the respirator is properly seated in the face. Positive pressure on the exhalation valve, you put on and you apply positive pressure from the inside, blowing in on it. Negative pressure, if you have these types of filters, you'll put your thumb over the holes or put your palm of your hand over the full canister and breathe in, and you shouldn't feel any leakage around any of the seals in either cases. Continuing respirator effectiveness. We want to maintain appropriate surveillance of the work area conditions and degree of exposure or stress. Reevaluate the respirator's effectiveness when it may be affected by changes in the workplace. Employees must leave the respirator use area to wash their faces and respirator facepiece as necessary, to replace respirator or filter, cartridge or canister. If the employee detects vapor or gas breakthrough, changes in breathing resistance, or leakage to the facepiece, the employer must replace or repair the respirator before allowing the employee to return to the work area. Procedures for immediately dangerous life and health situations. You have one or more employee, or when needed, more than one employee must be located outside the IDLH atmosphere. Visual voice or signal line communication must be maintained between the employee inside and outside. Employees located outside must be trained and equipped to provide effective emergency rescue. The employer authorized designee must be notified before any employee outside the IDLH atmosphere enters to provide emergency rescue. Employer or authorized designee, once notified, must provide necessary assistance appropriate for the situation. IDLH continued. You want employees located outside the IDLH atmosphere must be equipped with a pressure demand or other positive pressure self-contained breathing apparatus or supplied air with auxiliary self-contained breathing apparatus, and either an appropriate retrieval equipment for removing employees who enter, where retrieval equipment would contribute to the rescue of the employees, it would not increase the overall risk resulting from entry, or equivalent means for rescue where retrieval equipment is not required as listed above. Okay, procedures for structural firefighting. Yep, in addition to the procedures for IDLH, there's a section in here on firefighting. At least 2 employees must enter and remain in visual or voice contact with one another at all times. At least 2 employees must be located outside. All employees engaged in interior structure firefighting must wear SCUAs, self-contained breathing apparatus. One employee located outside may be assigned an additional role, for example, incident commander, so long as this doesn't interfere with their assistance for rescue activities. Standard does not preclude firefighting from performing emergency rescue before an entire team has assembled. Sorry. Okay, now we're on to maintenance and care. Respirators must be clean and orderly condition. We want to provide each user with a respirator that meets these requirements. Use procedures in Appendix B2 or equivalent manufacturer's recommendations. You want to clean and disinfect at the following intervals: as often as necessary, when issued for exclusive use, before being worn by different individuals when issued to more than one employee, after each use for emergency respirators and those used in fit testing and training. Let's keep sliding on me. Okay. Breathing air quality and use. Compressed breathing air must meet at least the requirements of Type 1 Grade D breathing air, as described in ANSI and the Compressed Gas Association's G1 7.1 1989. The oxygen content of 19.5 to 23.5%, hydrocarbon condensed content of 5 milligrams per cubic meter of air or less, carbon monoxide content of less than 10 parts per million, and carbon dioxide content of 1,000 parts per million or less, and lack of noticeable odor. Breathing air quality use continued. Compressors supplying breathing air or equipment with a suitable inline air purifying sorbent beds. Let's see some of these over here. Filters that are maintained, replaced, or refurbished per manufacturer's instructions. Compressors that are not oil lubricated. Breathing air carbon monoxide levels greater than 10 parts per million. The oil lubricated compressors require an alarm to monitor carbon monoxide levels. It has to be either high temperature or carbon monoxide alarm or both. If only high temperature alarms are used, the air supply must be monitored at a sufficient intervals to prevent CO levels from exceeding 10 parts per million. This should be less than 10 parts per million up here. Cartridges and filters and their identification. All filter cartridges and canisters used in the workplace must be labeled and color-coded with a NIOSH approved label. The label must not be removed and must remain legible. The TC number that used to be used is no longer used on cartridges or filters under 19 Part 84 CFR. Marked with NIOSH, manufacturer's name, and part number, an abbreviation to indicate the cartridge or filter type, for example, N95, P100, etc. Matrix approval label supplied usually as an insert in the box. Training and information. Employers must provide effective training to employees who are required to use respirators. This training, employees who are required to wear respirators must be trained such that they can demonstrate knowledge of at least the following: why the respirator is necessary, and how improper fit, use, maintenance can compromise its protective effect, limitations, capabilities of the respirator, effective use in emergency situations, how to inspect, put on, and remove, use, and check the seals, maintenance and storage, recognition of medical signs and symptoms that may limit or prevent effective use, and general requirements of the standard. Training must be provided prior to use, unless acceptable training has been provided by another employer within the past 12 months. Retraining is required annually, and when changes in the workplace or type of respirator render provisions previous training obsolete. There are inadequacies in the employee's knowledge or use. Any other situation arises which retraining appears necessary. Voluntary use. The basic advisory information in Appendix D must be provided to employees who wear a respirator when it is not required by the standard or by the employer. Program evaluation. Conduct evaluations in the workplace as necessary to ensure effective implementation of the program. Must conduct evaluations. Must regularly consult employees required to use respirators to assess their review on program effectiveness and to identify and correct any problems. Factors to be assessed include, but are not limited to, respirator fit, including the effects on workplace performance, appropriate selection, proper use, and proper maintenance. Record keeping. Records of medical evaluation must be retained and made available as per 29 CFR 1910-1020. A record of fit tests must be established and retained until the next fit test is administered. A written copy of the current program must be retained. The written materials required to be retained must be made available upon request to affected employee and OSHA. Here are some of the references that we used to develop this webinar. And if you want to visit our website, you can see it here. You can find a lot of information on that site, and that precludes our webinar. You can contact me, Brian Brocker at iup.edu. Our office number is 800-382-1241. You can see our website, and all this will be available on our website as well. And you can see our Facebook site and our Twitter address as well. Our upcoming webinar is Beryllium and the OSHA standard, October 5th, 22 at 10:30. And that concludes our presentation. I appreciate your time. Thank you.